Here we're going to look at topic 19, example 1, where we solve systems of equations using substitution. What is the solution of the system of equations? And we're given two equations, y equals 6x plus 7 and 3x minus 8y equals 4. So what we have here is y is equal to 6x plus 7. So what that means is anywhere there's a y, we can replace it with 6x plus 7. So that's what I'm going to do with this second equation here. If you have a variable already isolated, you're able to substitute, which is why this is called the substitution method. So that y is going to become 6x plus 7. It's the same thing as if you were substituting a number. So if I told you like y was equal to 2, you could substitute a 2 in. Well, instead of a number or a constant, what's going to happen? It'll be equal to an expression. So we're going to substitute that expression in. Now, you'll notice that we have an equation that only has x values, so we can solve that. All right, and to do that, my first step would be to distribute. You do want to be careful, make sure you are distributing the negative 8, all right, not just the 8. So we're going to get negative 48x, and then negative 8 plus 7, negative 8 times 7 would be negative 56, and then that would be equal to 4. So we would continue from here, keep solving this as if we would solve, as we're solving an equation. So combine like terms, 3x minus 48x will be negative 45x minus 56 equals 4. I would then add 56 to each side. Get negative 45x equals 60. And I would then divide by negative 45. We will get a decimal here. What I'm going to do is I'm going to reduce this as a fraction and write that as negative 4 over 3. So this is the first part of my solution. It's my x value. Okay, so x is equal to negative 4/3. Now, the second part of this process is you need to figure out the other variable. We need to figure out what y is. So I'm going to take the equation y equals 6x plus 7. I can actually use either equation, but I'm going to use that one. And what I'm going to do is I'm going to replace the x value with what I know x is equal to. So we'll say y is equal to 6, and we're going to substitute negative 4/3 in for x. And now I can just solve for y because it's the only variable left. So 6 times negative 4, that would be negative 24 over 3 plus 7. Negative 24 divided by 3 would be negative 8. And negative 8 plus 7 would be equal to negative 1. So I now know that y is equal to negative 1. So my solution are my x and my y values. And remember when we talked about graphing these, solving by graphing, our solution was a coordinate point. So we're going to write these as a coordinate point of negative 4 over 3, or negative 4/3, and y is negative 1. And that would be my solution. So the whole process, it's pretty straightforward, right? It's called substitution because you are substituting. What's important is that you need to have a variable that is isolated. If you look at the triad examples on the bottom, here we have x is by itself. So I would replace the x value with y plus 6. Right. In part B, y is isolated. So I would replace the y value with the 2x minus 1. If no variable is isolated, you are going to need to isolate it first before you can use the substitution process. But sometimes that's not too bad. It can be quicker or a quick process to do it, but sometimes you'll use graphing, will be easier. Sometimes next process that you'll learn is elimination. Sometimes that'll be easier. But substitution is a very important kind of skill or tool that you should have. And you're going to solve a lot of systems of equations using substitution. So make sure you grasp this and learn it and know how to do it.